Today we will learn about a theorem. There is an irrational number between any two rational numbers. Let's see the proof of this theorem. Today we will learn about the theorem. There is an irrational number between any two rational numbers. Let x1 and x2 be any two rational numbers. Position of any two rational numbers. अब हमें ये प्रूव करना है कि x1 और x2 के दरमियान कम से कम एक इरेशनल नंबर होगा. On the line of real number there lies x1 here and x2 lies here. On the line of real number x1 is placed at here, x2 is placed at here. x1 is rational and x2 is also a rational number. There lies an irrational number between these two numbers. x1 is rational, x2 is rational. There lies an irrational number between these two rational numbers. As x2 is greater than x1 because the number on the right hand side of real number line are greater than the number on the left hand side of real number line. As x2 is greater than x1 implies x2 minus x1 is greater than 0. In particular case, we are now manipulating this theorem to check that under the specific condition taking rational numbers 0 and 1, there lies an irrational number between 0 and 1 where 0 and 1 are the rational numbers. You know that 0 is less than 1. We are taking two values on the line of real numbers. हमने रैशनल नंबर लिए. ऑन द लाइन ऑफ रियल नंबर्स हमने दो रैशनल नंबर एक्सप्रेस किए और ये देखा कि ये जो वैल्यू है 1/√2, suppose that it lies here, it is an irrational number. Therefore 0, between 0 and 1 there lies an irrational number which is an irrational number. In particular case, there lies an irrational number between two rational numbers 0 and 1. Now we have to generalize the result. अब हमें line of real number के लिए ये result generalize करना है because on the line of real number there are infinite irrational numbers, infinite rational numbers and infinite irrational numbers. x2 minus x1 is a greater value, is a positive value, is greater than 0. To generalize the result for any two real numbers, there lies an irrational number between them. For this, we will multiply this equation by x2 minus x1. Multiply this inequality with x2 minus x1. Its answer will be 0 less than 1/√2 is less than x2 minus x1. We are adding. In particular, we take two values just to understand that how an irrational number lies between these two rational numbers. You are looking that an irrational number lies between 0 and 1. Now we have to generalize the inequality. As there are infinite irrational numbers on the line of real number, as x2 minus x1 is greater than 0, implies x2 minus x1 is a positive value. To generalize the inequality between any two rational numbers, there exists at least one irrational number. Now we will multiply this inequality by x2 minus x1. 0. Now we multiply this inequality with x2 minus x1. After multiplying it x2 minus x1, we get this equation. Putting x1 on both sides, we get x1 plus 0 is less than this factor plus x1 plus x2 minus x1. Value of x1 is 0, mentioned over here. As x1 is rational number, where x1 and x2 are supposed rational number. This number is sum of this value plus x1. And this value is x2 minus x1 is greater than 0. And 1 over square root 2 is an irrational number. Here an irrational number with rational number. Therefore, what is the result? Here product of rational and an irrational number is irrational by using the theorem. Also sum of rational and an irrational number is irrational number. Therefore, this value is an irrational number. Now, we are introducing mu. At the place of this value, we introduce mu, and mu is equal to x1 plus 1 over square root 2 into x2 minus x1, where mu is an irrational number. Where mu is equal to x1 plus 1 over square root 2 into x2 minus x1, where mu is an irrational number. Therefore, it is proved that there is an irrational number between any two rational numbers.